Okay, Year 10, so welcome to the last of your introduction videos for this week, which is just trying to put some of these questions into a more problem-solving style context, okay? So here's a question for you to have a go at. The Great Pyramid of Giza in Egypt has a height of 147 metres. Now, because it doesn't say, I think what you have to assume there is they mean the perpendicular height is 147 metres, okay? Its square base has a perimeter of 921 metres. Use these measurements to calculate its volume in metres cubed, rounding your answer to three significant figures. So I would like you to have a try at it yourself first. So stop the video and have a go. Okay, here's the solution. Okay. Now, since the square base has a perimeter of 921, one of the sides must be 921 over 4, okay? Then we know that the volume is a third times the base area times the height. So it's 1/3 times 921 over 4 squared, that's basically the length squared, times the height 147, which gives this crazy number here, and then change that into three significant figures, okay? Right, what about this one? Okay, so this time a hemisphere has a diameter of 21 centimetres. Work out the volume of the hemisphere, rounding your answer to three significant figures. Stop the video and have a go. Okay, first things first, the volume of a hemisphere must be 4/3 pi r cubed over 2, okay? And you're not given r here, you're given d, you're given diameter. So diameter's got to be 10.5. So we're going to do 4/3 times pi times 10.5 cubed, and then we're going to half it. That will give us the volume of the hemisphere, okay? And that gives me an answer of 2420 centimetres cubed to three significant figures, 2420 centimetres cubed. All right. Okay, any problems with that, let me know. Finally, what about this one? This shape here is called a frustum. And a frustum is essentially a cone, but where the top of the cone has been sliced off at some point, okay? So the radius of the frustum's smaller circular face is 6 centimetres, so that's telling you that there. And the larger circular face is 20. The diameter of the larger circular face is 20, so this distance is 20. Okay, and the height of the frustum is 8. And you're also told an additional piece that the height of this cone that's kind of been sliced off is 12. So can you find out the volume of this frustum? Okay. So stop the video and have a go. Right, now, all you really need to do here is imagine that you place the sliced off cone back on. What is the volume of that sliced off cone? So I'm going to call that volume of the small cone. Well, that's going to be 1/3 times pi times 6 squared times its height, which is 12. Okay, and then what would be the volume of the large cone if the small cone was placed back on? Well, it would be 1/3 times pi. This time it would be 10 squared, not 20, because the diameter is 20, not the radius. So it'd be 10 squared times the height of the whole cone would be 20. And all you're going to do is take this answer and subtract this answer here. And that should give you, rounding off to 2 decimal places, there is the answer in centimetres squared. Okay? So I hope that's easy enough. If there are any problems with any of those questions, just ask. Okay? Now, have a look at this question here. This is a challenge question. I'm not going to give you the answer to this. I would like you to submit your answers to me, please. Submit your solutions, not answers. I would like a detailed written solution for this. You can send me that, send me a picture on Teams would probably be the best way, or Firefly, whatever suits you, but Teams is probably easier. So the question is, a cone is placed inside a sphere as shown. The sphere and the circular base of the cone have the same radius. And that, obviously, hopefully that's obvious why that makes sense. Because that cone fits exactly inside. It's both the radius of the cone and of the sphere. And the height of the cone is equal to the radius, which again, hopefully makes sense given the picture. Okay? So what we want to know is what fraction of the sphere is occupied by the cone. What fraction of the sphere is occupied by the cone? So this is where we're going to find out whether you really understand fractions. All right? So have a go at that and submit some solutions onto Teams, please. Don't be afraid to have a go at it. Whenever we do this, usually about 6, maybe 7 of you that do it. I would like everybody to have a go at this. By the way, although this is a challenge question, I have seen past paper questions on tests that are very similar to this. Okay? So please have a go at it.